Hello and welcome, class. So yours truly, I'm Engineer Ronjon R. Garmi, and this is Engineering Geology. So our topic for today is geophysical investigations. As for our learning objectives, at the end of the session, students will be able to first describe the relation between geology and geophysics. Then explain the importance and necessity of geophysical investigations. And then describe different geophysical methods in terms of the principle and the controlling physical property. And finally, relate with various geophysical anomalies in geophysics. So to start with, we have to compare geophysics and geophysical investigations. Well, geophysics is the study of the earth by making use of established principles of physics. Of course, when we say physics, we are talking about the physical attributes of various geomaterial that is known to be on the upper crust of our earth. So what will be provided in geophysics will be data on Earth's crust, the data on the oceans, or data in the atmosphere. Geophysical investigations utilizes simple methods to ascertain subsurface details. Subsurface geology includes rock types, the structure within the subsurface, the ore deposits that are present, and the existing groundwater conditions. So geophysics has two branches. First, we have the general geophysics. So the general geophysics, the context is the study of Earth as a whole and its major concept. Investigation of various physical fields occurring on Earth, which includes gravity fields, magnetic fields, geothermal fields. It gives information about physical state and composition of matter in the Earth's interior. It helps us understand about the Earth's crust, mantle, core, the crustal thickness, or the presence of major discontinuities and the like. So, geophysics has two main branches. So, the second one is the exploration geophysics. So, this is also known as geophysical prospecting or applied geophysics. Is primarily made for the study of relatively shallow subsurface inhomogeneities and structures. So we are exploring for a site-specific requirement wherein our exploration will be limited only to a shallow depth or the subsurface above the Earth's crust. So the investigation of this exploration geophysics signifies an economic importance, like the exploration of oil and gas. So this is actually a resource. And then the ore deposits, so it implies the resources of the earth, and the existing groundwater condition, potential for water source, and of course it is mainly aimed for us to deal with geohazards, or what we call the engineering intervention. So the exploration geophysics has also branches. We have actually 5. First, we have the regional geophysics. Of course, this is needed in dealing with geohazards, wherein we are concerned with the boundary conditions or the presence of faults and folds. And then we also have the oil and gas geophysics. Of course, this is for extraction of our resources, as well as the ore geophysics, the extraction of the ore, gold mining, the silver, and the like. We also have the groundwater geophysics, of course, related to resource extraction also, as well as evaluation of geohazards. Because groundwater is also an input parameter in geohazards like the landslides. And then finally, the engineering geophysics. So let us have this why geophysical investigation necessary. Of course, to ensure the feasibility and viability of major civil engineering structure in terms of safety, success, and economy. Of course, all of this will come in if we have a good data gathering that would be input to our engineering design. Another significance of geophysical investigation, it is actually an indirect inferences that is more practical to direct observations. So direct investigations include digging, trenching, or drilling the ground, which are impractical, costly, labor extensive, and time consuming. Normally, we have the so-called borehole in order to have a direct investigation. And as discussed before, borehole includes highly technical operators, sophisticated equipment, and expensive investigation or drilling. While in an indirect inferences, subsurface details can be obtained in a more practical way. So it is quick, easy, inexpensive, and fairly reliable. But we have to take note that the direct investigation provides us a more accurate data. So in using or utilizing indirect inferences, it must be utilized with caution, in which we should have to validate the inferred data with that of the measured data. So this is done with the existing literatures or a finished study that could relate to our investigation. So basically, the inferred data could be strengthened by the existing measured data, preferably nearest to the site conditions that we are investigating. Well, in here, outcrops can be supplemental, but absence of other subsurface data should also be inferred because of course, we cannot really obtain the other data because of the soil covering, or there is the presence of intense weathering of exposed rocks. And then we are being constrained also by spreading out of cultivated lands or urbanization or artificial land use. Like for example, in places of mountainous terrain which are highly urbanized like Baguio City, we cannot directly access an investigation by direct methods. So basically, we will resort to a destructive method in data gathering, which is also discouraged. So in our investigation, we are also constrained by the presence of vast forests. If there will be a forested land, expect that there are large trees that may prevent us to access to a direct investigation. Again, we might resort into a destructive method in our investigation of the subsurface. And of course, the presence of bodies of water could also constrain us in our investigation of the subsurface. So these are the factors. So what would be the advantages of geophysical investigation? First, quick investigations are carried out. Instruments are simple, portable, and non-laborious. It does not require the use of consumables like chemicals, and it is economical in a way that the work is quick, where only physical observations are made. Moreover, investigations are amenable according to survey requirements. In fact, the scale of survey can be selected. Like for example, if we are only concerned with preliminary data, of course, we opt to use a large scale, say 1:100,000 or to 1:1 million. If we are concerned for a more detailed one, we could use around a smaller scale ranging from 1:1,000 to 1:10,000 scale data. Geophysical investigations applications. So it could be non-geological. Actually, this geophysical investigation were first utilized during war, wherein they are detecting hidden treasures and locating ammunition dumps. Or in construction, we are concerned with the buried pipelines. So applications also within the could also be within the context of geological. Of course, solving problems on regional geology. Again, this is relating to the stratigraphy of the site, the structures on site. Of course, we are concerned with the groundwater level at a certain depth and the permeability of the geomaterial on the Earth's interior. So, another geological, we have locating geological structures favorable for economic use, like oil and gas, and of course, estimation of important mineral deposits like ore deposits, locating groundwater source. So of course, we are concerned with the location and its quality. And again, for geological parameter, This is relating to engineering intervention on geohazards. So for engineering geophysics, of course, if we are relating to engineering, we are more concerned on the properties of the supporting soil or geology for our foundation. So our concern is the subsurface rock formations and their depth, and the presence of faults and joints, the determination of the thickness of overburden. So the overburden refers to the bedrock depth. Of course, the bedrock is characterized or known for its strength. Next is the demarcation of the basement relief. So the basement relief refers to the bedrock profile along the orientation of a structure. Of course, these details would be of great reference for a safe site or location for a huge structure like dams and reservoir. And then engineering geophysics would also enable us to locate fault zones or shear zones. So of course, the location of those zones are normally places of leakage for reservoir or canals. Then we also have locating buried pipes. So this can be carried out by magnetic methods. Then the pipes carrying oil and gas are normally facilitated by electrical methods. And then engineering geophysics also facilitate us or enable us to detect regions of mounting high pressure in mines. So this can be carried out using piezoelectrical methods. So it could also enable us to locate underground fire. So this is by geothermal methods. And then of course, as engineers, we are concerned with locating the major cavities in huge structure like dams, because cavities would be the start of the dam failure or your structure. So this can be carried out by radio wave absorption method. Okay. And then another concept or scope of engineering geophysics is the determination of heat losses in power grids. So this can be carried out again by geothermal and infrared scanning. So what is the principle behind geophysics exploration? So rocks or ore bodies have varied physical parameters in terms of compactness, the size, the shape, the thickness, the fracture, strike and dip, fracture zones, and intrusion. So these differences have their corresponding differences in the density, magnetic susceptibility, elasticity, radioactivity, thermal or electrical conductivity. So basically, geophysics measures natural field like gravity, magnetism, and natural electric field. So measures the response of the subsurface to the artificial energization. So diagnosis can be based from geophysical anomalies to possibly delineate geological objects, rocks, ores, and the like. So what are these geophysical anomalies? We can see here in the figure that points A, B, C, D, E are stations of our equipment or the point of test. So in here, the first anomaly is the nature of gravity profile over homogeneous surface. So the readings of gravimeter will be nearly the same at all station observation along traverse. So as you can see in the graph, that the change in gravity reading will be almost the same. Okay, hence we have a horizontal profile. So this is what we call the uniform gravity profile. So the next geophysical anomalies, we have nature of gravity profile, where subsurface is horizontal depth. So this is nature of gravity profile, where subsurface of horizontal bed. So it is similar to the first one, of course, but as you can see, there are presence of heavier beds. So it can be observed that there are higher values that can be observed from the gravimeter, but not that substantial difference. So as you can see on the graph, we have almost horizontal one, but there are also presence of higher or heavier layer on underneath. Okay, as you can see from the figure, we have the first layer to be lighter at 2.2 grams per cubic centimeter, and then the next layer will be 2.5 grams per cubic centimeter, and the third layer will be 2.8 grams per cubic centimeter. So this is just an example of uniform gravity profile with higher values because of underlying heavier loads. So as we go deeper, we have materials that are heavier, going heavier values in terms of the density. Like the first one, we have a uniform material here. We have the homogeneous surface with the majority of material are in 2.7 grams per cubic centimeter. So the nature of gravity profile, where the subsurface of horizontal bed, there are bed of layers. Of course, on each layer there will be homogeneity. So when there is no homogeneity, there could be a presence of a salt dome. So there will be a sudden decrease of the gravimeter reading. So salt dome are normally enclosed by relatively denser formation. So heavier formation enclosing the salt dome. So as we can see, the country rock here is heavier than that of the salt dome with a density of 2.2 gram per cubic centimeter. So this is one geophysical anomaly that reflects negative anomaly. So this produced a gravity profile with negative anomaly. So next, so this is a geophysical anomaly wherein the nature of gravity profile when the subsurface has undergone faulting. A relatively higher formation has moved downwards and is occurring surrounded by a denser rock mass. Gravimeter readings recorded above the lighter formation show lesser values, thereby producing a negative anomaly in the gravity profile. So, on the stations, you can see that on center we have a lighter material that is moving upwards because the material surrounding it is heavier, so it moves downward. Hence, faulting is manifested. So in here, we have the nature of gravity profile when subsurface has a synclinal fault. So it is evident that here we have a synclinal shape. Okay. So normally a synclinal shape is in the form of convex curve underneath. So in here, there are more heavier material on the central part, wherein lighter material is also observed with a certain thickness surrounding that heavier central material. So in here, the younger, denser beds have produced a positive gravity anomaly. In this syncline, the central region has a heavier bed surrounded by a relatively lighter bed outwards. Of course, the lighter beds are under that of the heavier beds on the central portion, but majority of the heavier portion is found on the central portion. That is why the gravity profile has a positive anomaly. So of course, if the trend of density of beds is the reverse, the overlying beds are successively lighter, negative gravity anomaly appears even though the fault is synclinal. So in here, we have the gravity profile with positive anomaly. The nature of gravity profile when the subsurface has an anti-synclinal fault. So this is the reverse of the synclinal fault, wherein the shape is a concave shape. So this time we have the older layer will be the outwards of the anti-synclinal shape, which is predominantly the heavier, younger material. So this is normally surrounded by a lighter material, of course, the sigma 1, that is 2 grams per cubic centimeter, and then the outer layer of your anti-synclinal fold is 2.4 gram per cubic centimeter. So that is lighter than that of the majority of the central material of 2.6 gram per cubic centimeter. So hence, just the same, it will produce a positive anomaly on the gravity profile. And then we have here the last geophysical anomaly. The gravity profile here is observed to be in sloping. So this is where the nature of gravity profile when the subsurface has tilted beds when the older ones possesses successively increasing densities. According to the increasing or decreasing densities of the beds along the deep direction, gravimeter readings gradually vary and cause for appearance of a sloping gravity profile. So those are geophysical anomalies that we can refer to. So the principle of these geophysical anomalies is on gravity methods. So gravity methods represents a set of geophysical methods which make the use of the natural gravity field of the Earth. So it was observed in the anomalies that the density is the controlling physical property. So the nature of distribution of gravity on the surface is analyzed. G is positive if the causative body is heavier, larger, and occurs at shallow depth. Thus, in a particular region, if subsurface bodies such as ore deposits, coal, seams, and salt domes, whose densities are different from the surrounding rocks, exist, the gravity field deviates. There is a varying values from the normal value that is expected if the inhomogeneities are not present. From these deviations, it is possible to locate the inhomogeneous bodies in our subsurface. So gravimeter is a mass-loaded spring. So you can see it in here. In figure 8, for a heavier body, the spring extension is becoming longer. For a lighter body, the spring contracts becoming shorter. In figure B, there is the effect of the depth. If the subsurface has relatively heavier body at a shallow depth, the gravity effect is more positive. And if such a body lies at a greater depth, the gravity effect is less on that particular location. In a particular region, if subsurface bodies whose densities are different from the surrounding rock exist, of course, we can see the variation as mentioned. Okay? So this ends our lecture for today, and I hope you absorb all the concepts that was discussed. So thank you for listening and have a good day.